Good morning to all. Electrical machinery 2 subject laboratory test. In this chapter 2 test practical experiment proof single phase motor, that is single phase induction motor. These motors have output less than 1 horsepower or 1 kilowatt, hence are called fractional horsepower or fractional kilowatt motors. AC single phase fractional kilowatt motors perform variety of service in the homes, offices, business concerns, factories, etc. Almost in all the domestic appliances such as refrigerators, fans, washing machines, hair dryers, mixer grinders, etc. Only single phase induction motors are employed. Electrical machinery 2 laboratory experiment, that is practical lab. Subject: predetermination of equivalent circuit of single phase induction motor and load test on single phase induction motor. Aim: to predetermine the equivalent circuit parameters of the given single phase induction motor and to obtain the performance characteristics. Nameplate details: capacity 2 HP, current 8 ampere, frequency 50 Hz, voltage 230 volt, synchronous speed 1500 rpm. Fuse rating: no load test 230 into x is equal to 230 into 30% of rated current, that is x equal to 230 divided by 230 into 30 into 8 divided by 100, 2.4 ampere. Therefore 5 ampere fuse will be appropriate. Kindly noted. Blocked rotor test: 230 into x, 8 into 20% of rated voltage, that is x is equal to 8 divided by 230 into 20 divided by 100 into 230, that is 1.6 ampere. 5 ampere fuse will be appropriate. Precautions: open circuit and short circuit test. The SPSD switch should be closed, that is important. During no load test and block rotor test, the auto transformer should be kept at minimum potential position. There should be no load on the breakdown for the no load test. Stator resistance test: there should be no load at the time of starting. The SPSD switch should be kept open, that is important. Connection diagram no load test, that is connection diagram 1 shown in notes. Supply: single phase supply applied. An auto transformer single phase 230 volt to 0 to 30 volt connected, and voltmeter and ammeter are connected, and multimeter connected. Main winding and auxiliary winding of motor connected. SPSD switches and open position. Capacitor is connected, that is capacitor single phase induction motor, and brake drum is T1 and T2 are availability. That is no load test circuit diagram. Procedure: connections are made as per the connection diagram 1. Observing the precaution that DPSC switch is closed. The auto transformer is adjusted till the rated voltage of the machine is reached and all the corresponding meter readings are noted. Blocked rotor test. Connections are given as per the connection diagram 2. Observing the precaution that DPSC switch is closed. The rotor is blocked so that it will not rotate. The auto transformer is adjusted such that the rated stator current is reached. This is maintained for some time to allow the stator windings and rotor parts to reach the normal working temperature. The meter readings are noted. Circuit diagram of blocked rotor test, that is second diagram. Circuit diagram of block rotor test, kindly shown in notes, that is single phase supply, an auto transformer, and voltmeter, ammeter and multimeter. Main windings of motor and auxiliary windings, and that is capacitor single phase induction motor used, kindly shown in notes. Stator resistance test. Connections are made as per the connection diagram 3. The control rheostat is initially kept in either maximum resistance or open position. Observing the precautions, the DPST switch is closed. The control rheostat is varied in steps, and at each step voltmeter and ammeter readings are noted. Formulae: no load test. Cos theta is W0 divided by V0 I0. R0 is V0 divided by I0 cos phi 0. X0 is V0 divided by I0 sin phi 0. Put required values, we obtain that values. In this way, block rotor test values are obtained. Calculation of performance values. Assume value of slip S between 0 and 1. We obtain ZF and ZB value. I is equal to V divided by Z. Cos theta is equal to R divided by modulus of Z. VF is I into ZF. VB is I into ZB. I 2F dash I 2B dash and TF dash is find out from formula. Condition diagram 3 shown in notes. Stator resistance measurement test. In this test, single phase supply is applied and ammeter is connected and main winding is connected, voltmeter connected and control resistor 10 ampere control resistor is connected. Shown in circuit diagram shown in notes. dB is backward direction torque and synchronous watts. Torque developed T net is equal to TF minus dB in synchronous watts. Output in watts T net into 1 minus S. Speed N is equal to Ns into 1 minus S RPM. Output power in kilowatts is equal to output power in watts divided by 1000. Input power is VI cos phi. Efficiency is output power divided by input power into 100. No load test. Wattmeter MF is 4 voltage V0 230 current I0. Wattmeter observed reading actual power consumed on no load W0 speed 1435 RPM. Block rotor test. Wattmeter MF 1 voltage VB current IB. Wattmeter observed reading and actual power consumed WB 350 watts. Stator resistance measurement test from resistance value obtained. AC value of resistance value is 1.2 into our average. Tabular column, we find out that our average value. Graph shown in notes. From this graph we obtain torque, speed and a percentage of efficiency, cos phi, I, speed, torque. Graph is shown in figure. We obtain torque waveform. In tabulated result we obtain output, speed and efficiency. From output we obtain that is less than 1 horsepower. Or less than 1 kilowatts. That is from obtained from tabular column. Equivalent circuit of single phase induction motor. That is shown in notes. The circuit consists of single phase and R1 resistance and X1 inductance and parallel formats of R0 X0 and R2 dash X2 dash and R0 divided by 2 X0 divided by 2 R2 dash divided by 2 into 2 minus X2 dash divided by 2 forward and backward format. Kindly shown in notes the circuit diagram. Specimen calculation, no load test. Cos theta naught is W naught divided by V naught I naught. R naught is V naught divided by I naught cos phi naught. X naught is V naught divided by I naught sin pi naught. Block rotor test. Cos theta B is W B divided by VB IB. Z is equal to VB divided by IB. RT is Z cos theta B. XT is equal to Z sin theta B. R2 dash is RT minus RL. X2 dash is equal to XL is equal to XT divided by 2. Assuming X2 dash is equal to X1. Calculation of performance values. Assume values of slip S between 0 and 1. That is important. For slip S is equal to 0.2. R2 dash divided by 2S. R2 dash divided by 2 into 2 minus S. X2 dash divided by X2. HHF. That is find out from calculations. ZB and ZI value. Cos theta BF VB I2F dash I2B dash TF TB values are from using formula from calculations, that values are find out. Torque developed T net TF minus dB in synchronous watts. Output in watts T net open bracket 1 minus S close bracket. Speed N is equal to Ns divided by 1 minus S RPM. Output power in kilowatts. Input power VA cos 5%. That is find out from formula. From this value we form tabular column. From this tabular column obtain graph. From this graph we find out torque and efficiency. value results as the parameters of the equivalent circuits of the given single phase induction motor and the performance characteristics are predetermined. Thank you. That is second experiment of laboratory experiment of load test on single phase induction motor. Aim to conduct load test on the given single phase induction motor and obtain its performance characteristics. Nameplate it is capacity 2 HP, current 8 ampere, frequency 50 Hz, voltage 0 reverse synchronous with 1500 rpm, 125% of rated current, 10 ampere. Precautions: the DPSD should be kept open initially, that is important. There should not be any load at the time of starting. After the motor has picked up speed, the SPSD switch is open. Procedure: the connections are made as per the connection diagram. The SPSD switch is closed, the DPSD switch is closed, and the AC supply is affected and corresponding no load readings are noted. Then load is applied gradually, and for each load the corresponding meter readings are tabulated till a current slightly above the rated current is reached. Formally, input power torque, output power in kilowatts are given in notes, and formula of efficiency slip power factor is given. Shown load test on single phase induction motor and nodes. Single phase is connected, an auto transformer is connected, voltmeter, ammeter and connector, motor, capacitor, single phase induction motor are connected, and multimeter are connected, and load brake drum are connected, kindly shown in circuit diagram. From this circuit connections are made, we apply the load, find out the tabular columns of readings. From these readings we obtain output power is less than 1 horsepower. Kindly noted. Graph is drawn from tabular column. From this specimen calculation is given in notes. From this graph, ILPA percentage of efficiency, torque, speed versus output in kilowatts. Results: as the load test on the given single phase induction motor is conducted and the performance characteristics are drawn. Kindly shown in notes. Thank you.